In the present work, the finite element analysis was employed to study the distribution of mechanical stress generated in metal ceramic bimaterial. A micromechanical model is proposed to explain a phenomenon of defect observed in the metal ceramic interface. The distribution of this stress in the ceramic around this defect was the subject of a numerical analysis using the finite element and method. The analysis has been extended to the effect of defect-defect interaction, defect size and form. A three-dimensional finite element analysis is developed for this investigation. Here, the silver border to ammonia is selected in this study. Here, the distribution of normal and von Mises equivalent stresses are highly concentrated near the defect. Here, the defect is at a special place of stress concentration by notch effect. Here, the presence of this defect on the surface of the ceramic related metal plays a leading role of stress concentration, whose intensity increases with the increase in mechanical loading of the junction. Here, the large defects induce more significant stresses, and the stress concentration factor varies almost linearly with the variation in size. Here, the decrease in the parameter x by y involves a high stress concentration factor. The interface defect having such a form is the seat of stress concentration. Conclusion: the sites of interface defect during the elaboration by interfacial friction with the silver are the privileged places of stress concentration by notch effect. The level and the distribution of the normal, tangential and the von Mises equivalent stresses are not dependent merely on the intensity of mechanical loading, nevertheless also on the size of sides of interface defect. The stress concentration factor grows with the increase in the volume, thus the coarse interface defect do concentrate more stresses relative to the small ones.